everyone, welcome back to OneTouchBI. This is me Saravanan Vajravel, and today we are going to learn in our class how to detect irregular shapes and its size using the Python image processing coding technique. And for our today's exercise, I'm going to primarily depend on OpenCV image processing and SKImage package for determining the sizes of each individual object in the image, and the custom utility package ImUtils from PyImage Search is the one I'm going to use to align and optimize the contours that was written by OpenCV package. This is the image I'm going to pick up for our today's exercise, and then I'm going to contour the area of each individual object in the image. Let's understand what is contour. A contour is nothing but an outline of each individual object in the image. As you see in the left side, it's a before image processing, and after image processing in the right side, you can see that each individual object is being highlighted with the border line. That is nothing but contour. And after you highlight the contour, we are going to identify the midpoint of each object, and that was highlighted with the plus mark. After you highlight the midpoint, what we are going to do, we are going to calculate the distance between these two midpoints, and that is nothing but width and height of each individual object. As you see, 50 cm by 48 cm is the first object size, and similarly the rectangle one is 36 cm by 118 cm is the height and width of the image. We are clear? How we are going to achieve this? It is our exercise for our today's demo. Without much delay, let's quickly head over to my Jupyter notebook and program this from scratch. Create the new Jupyter notebook by clicking on File, New Notebook, Python 3. Let's name the program, and to name the program we can start with the # command line and name it Detect the Irregular Image Size from the source image. This was our tagline for our today's program. And contour the area and print the size. As I mentioned in the previous slide, I'm going to primarily depend on the OpenCV, SKImage, and ImUtils package, and the remaining, of course, we know that we will use the Matplotlib library and other required packages. Let's import all of these packages in the very first segment. Import CV2, import ImUtils, import ImUtils.perspective, and name it as alias PRSP, perspective. Why am I interested in perspective? And this is the package will help me to order the contour coordinates. That is left, top, right, and bottom. Okay, we are good. And the other package what I'm interested is import SKImage, and I'm interested only in calculating the distance. For that I need to use the module called spatial, and inside the spatial I'm interested in the function called distance, and name this alias as dist. You got it? Okay, what else? Next is to display the image in the matplot axis. Import matplotlib, and I'm interested in the module called pyplot, and this I'm going to alias as plt, and then I'm interested in import numpy, alias this as np, because every image is finally getting stored in the form of array. So I'll be assigning the image results to the numpy and then make it as an empty image. So you can see that piece of code in the bottom, and you will come to know what is the purpose of using the NumPy. Okay. So let's import the NumPy package, and then the next one I'm interested in is for the folder navigation OS package. I guess I'm pretty much included all the prerequisite packages. Let's run this by holding the Shift plus Enter key. Now we are good. The next is to read the image. Before we read the image, we need to set the image path. Set the image path to read the image. I'm going to set the image path with a variable name called image path equal to enclose with the single quotes and provide the path. Current directory, I'm going one directory back, and here is my folder which has all the images. After that, we need to change the directory. Change the directory to the image path. Using the command os.chdir and provide the image path that you assigned in the above line. That is image path. Now you have changed the directory to the image path directory. The next what we need to do is we have to read the image. I'm going to assign the image to img variable, and I'm going to read the image using the OpenCV package cv2.imread, and the image name that I'm interested in is size_img.jpg. After I read the image, this is going to return in BGR. All I have to do is convert the image to RGB for matplot. RGB_img equal to cv2 using the function cvtcolor, and within the parentheses you have to pass the image when you read img, and cv2.color all in caps underscore. I'm going to convert the BGR to RGB. That's it. We are good. Now let's print the image. plt dot. Before you print the image, let's define the image size. plt dot figure size equal to 15 by 15. Now I'm going to print the image using imshow command and pass the image what you converted now, RGB_img. We are good. plt.show. Let's print the image. Yes, we got the source image. Now show. Let's label this code, show the image. Okay. The very first part is done. We have read the image. Now we need to convert into the grayscale, convert into gray image or grayscale for detecting the contours, that is outline of each individual object. And let's convert the image. How do you convert the image? We have already done the code for converting the image from one color to another color. Let's copy this segment. We will rename this label later. I'm going to call this image is called gray, and img is the original BGR image. I'm going to convert from BGR to gray. In place of RGB, we are going to convert to the grayscale. After you convert to the grayscale, what we need to do, we need to remove the noises. Before that, let me print the image and show you how the image is looking like. Show the image in gray. plt.imshow of gray image. And before that, let's convert the image. Let's copy the line RGB image. because we need to convert the BGR scale to RGB. Let's do that. And this I'm going to call it as RGB underscore IMG. And I'm going to convert from BGR to RGB. And I'm going to print this RGB underscore IMG. And now you print the image. As you see, after you convert to the grayscale, the image is printed in this form. You can see that the background is still in the gray color. What we need to do, we need to remove the noise. The background you have to completely convert into the black part. How do we do that? And also you see that the arrow marks are coming with outlined white line. So everything we need to remove, and that removal is called noise removal. So let's do that. Remove the excessive noises using threshold. Using the function cb2.threshold, you can remove the further noises. You need to pass the image, the converted grayscale image, that is gray, and define the thresh value that I'm going to keep it 110. And how much brightness you want to keep it? I'm going to keep the maximum brightness, that is 255 for each individual contour object. The 255 indicates the white color, and the fourth parameter is cb2.thresh. That's the mode I'm going to apply for the threshold conversion. Thresh underscore binary. And this is returning two values. The one what you defined, the thresh value, and the second one is the image array. Let's assign the value, that is thresh comma thresh image equal to this value. Let's print it. Now you see the output is not getting printed in the Jupyter notebook. The values are assigned to the variable thresh and thresh image. Now we got the thresh image. All we need to do is we need to show this image so that we will have idea how exactly the grayscale image is converted to threshold image. To do that, let's copy this line as it is for displaying the image using the matplot function. And before that, as I said, we need to convert the image from BGR to RGB, and the image output is thresh underscore IMG, and show the image. We are good. You see that every image has been considered. Okay. Just to show you how this threshold number is going to differ, instead of 110, I'm going to keep it 140, and see that because of applying the higher threshold to remove the noises, I have missed out some of the image objects. So going higher, it is going to exclude my image objects inside the image. So let's not keep the higher threshold value, reduce it down. So let's keep 110. That looks good for me. And also I want to show you keeping this number to different scale. Let's keep it 200, and you see the output. Can you see each individual contour object, that is inside the image I have 13 objects, the color is dimmed. I'm going to keep it the maximum brightness, that is 255, the white. Now you see it's proper. So now you understood what is the purpose of the thresh value and the brightness of each contour object. Okay. So now we converted the thresh value. All we need to do now is detect the contours. That is our next step. Let's do that. Find the total contours. TOURS. Find the total contours. Using the OpenCV package, we can find the contours. The command for finding the contour is cv2.findCapC contours. Find contours, and the thresh image you have to pass, the one which we converted in the previous line. After you pass the thrush image, you have to apply the mode. What is the mode? cv2 dot retr list. You can use either return list or return tree. Both of them will give you the right contours. It is not going to miss any of the contour images. Okay, I'm going to use retr underscore tree, that's the mode. And the third parameter what I'm going to keep, here I missed this 2, cv2. Let's make that correction. And the third parameter is cv2 dot chain proximate approx underscore simple. That's the third parameter I'm going to pass it. It's called cv2.find contours. Let's run this code. You see that it's returning the array of value. Okay. Now we got the contours of all the 13 objects. Let's ensure is that return all 13 different contours in the image. To identify that, using the print command, print of len of the count. Before that, the find contour values, let's assign it to the variable called cons equal to this. And using the len function, I'm going to get the total number of contours. Let's print the label. Total number of contours by cv2. Print it. It returned 2. It is wrong. We have 4 plus 2, 6, 6 plus 3, 9, 9 plus 4, 13 objects. So the remaining 11 objects, it is not coming directly out of the find contour from OpenCV. How do we extract those remaining 11? That is where I said in the beginning, there is a custom package called IMutils from SKImage search. Using that, we will retrieve the remaining 11 contours. So what we are going to do now, the next step is fine tune the contours written by cv2 using IMutils. Cons equal to, using the IMutils dot, there is a function called grab underscore contours, and pass the contours that was written by OpenCV, that is CONTS. Now I have grabbed the contours that was written by OpenCV and assigned back to the same contour variable. Now let's print and ensure that you got the all 13 individual contour objects. And here you provide the label by IMutils. Okay, there you go. We got all the 13 individual contour objects. We are good. The next segment, what we need to do is we have to iterate the contours in the for loop and start highlighting the contour object. And before that, I want to create an empty object and draw the contours on top of that. I said in the beginning, contour is nothing but outline the object. Okay, I'm going to create an empty image with the original image size. Okay, let's comment it. Create the empty image with the original dimension. How do you do that? Let's provide the name that is called cont image, that's an empty image, equal to np, that is numpy, np dot zeros. I said all the images are getting stored in the array format, so I'm going to make np dot zeros within the parenthesis, apply the dimension of the image, that is the original image img dot shap. This will return you the dimension of the image width by height. And let's print this image plt dot imshow of cont underscore img. You can see that the image is printed with empty, nothing else is copied there. I'm going to show after this how does your contours are getting drawn on top of the empty image. Draw the contours in the empty image, that is cont underscore img. Using the OpenCV function cv2.draw contours, pass the empty image, that is cont underscore img, and pass the contour points that you have retrieved using the OpenCV, and later we have fine-tuned using the IMEtools package to get all the 13 contour coordinates. That contour variable we have to pass it, that is called CONTS. And the third parameter we need to define -1 so that we are not going to miss any of the contour objects. And the fourth parameter is the color of the contour, that I'm going to define 0, it's in the RGB format. I'm going to make all in green, 255, 0, and the thickness I'm going to make 2. And the function draw contour is going to return the image object. So let me assign the image back to the same empty object, cont underscore img equal to this. Let's print this image, show the image with contours. This time it's just going to highlight with outline, that is only outline, or you can call it as borders. Okay, so plt dot imshow of cont underscore img. Here you go, you got the contour of each individual object in the image. So now you understood how we have taken each individual object's contour area, and then using the IMEtools package we have fine-tuned all the contour points and then printed the contour surface only. Now let's go into the for loop iteration to print each individual contour object with the midpoints calculated, and also print the labels on top of each object, the size in either cm or inch or in pix format. Okay, so let's introduce the for loop. Loop over all the contour coordinates for c in conts. As we are aware, in the beginning the contour is written 13 individual objects inside the image, and each object of course will have the start point, end point, that is start point is nothing but left top and the end point is right bottom, and the score accuracy. So each contour object will have all this information. How do I extract this information? So what I'm going to do, I will extract the box points. Let's comment the line extract box points. Assign the variable box equal to cv2 dot min area rect of the contour point, that is C. You pass it. This will return the value. Let me print and show you. Box. You can interpret the value this way: left, top, right, bottom, and the accuracy. So that is assigned to the box variable. And next what we are trying to do, we are going to extract the box point from the previous output. We need to exactly get the bounding rectangle box coordinates. The bounding rectangle box coordinates we can interpret as left top, left right, and bottom left and bottom right. So there are 4 coordinates we have. So that point, how do we retrieve it? using the function called cv2.boxPoints. I'm going to assign that output back to the box variable. Box equal to cv2.boxPoints of box. This one will retrieve the output with a decimal point. So what I'm going to do, I'm going to convert the box points into integer. For that, I have to assign back to the original value box equal to np.array of, pass the box the decimal output, comma, d type equal to, make it integer. We are good. We converted back to the box with the integer format, converting all the decimal points. As you see here, 322.5, I'm going to make it as 322 so that the decimal numbers are taken out. Now let's draw the contour. Before we do that, let's make sure we have again created the empty image. Because just before in in62 I have created the empty image, but I shown how to draw the contour on the empty image. But now actually we are going into the loop iteration and printing each individual contour object one after another by identifying the size and then printing immediately the contour surface. So this is where we are going to do actual operation. So here I just shown you how to immediately draw the contour. So this section is not required, but just for our understanding purpose, I made it. So let's create the empty object. And this is the one I'm going to use to draw the contour in the loop iteration, one after another. That means in the very first, the first contour area will be drawn sequentially until all the 13 objects are completed. Okay, let's do that. So what is the function? cv2 dot draw contour. Draw contours, open parenthesis, and pass the empty image. What is the empty image we created? cont_img, followed by the second parameter. What we need to pass is the contour points. The contour point is, the first one is C. That means the first object will be drawn. After that, you need to define -1 parameter so that we don't miss any of the contour points. And the third one is the color. I'm going to keep the color simple, the green RGB, that is G is middle, 0,255,0, and the thickness I'm going to keep it 2. As we display the value of each contour, it has the start and end coordinates and it's coming in array format. So let's pass that value to the draw contours with a square bracket in array format C, which we are iterating over the for loop. So we are done. Let's print the output. Show the processed image with contours printed. Before we show the image, let's make sure we are increasing the image size using the function plt.figure of figure size. Within the parentheses, you define the ratio of the size, 15:15 I'm going to make it. And plt.show of plt.imshow. Within the parenthesis, where is our image stored? In this, it's called cont_image, cont_img, print it. There you go. We printed all individual contour once again using the for iteration loop. Now let's introduce the contour area so that I can control what contour objects I want to show. So every object will have the area defined based on the image width and height. So let's understand how the area is getting displayed. Okay, what I'm going to do, I'm going to introduce a if loop. If cv2 dot contour area of, in the for loop what we have assigned, in the for loop we are assigning the each contour to C. Pass the C. If this contour area is less than 900, let's make it 900, in that case I don't want to display the image. I just want to continue the loop. Anything which is greater than the contour area 900, I want to print it. So let's make this condition. So if anything which is under 900, I don't want to continue further the remaining code. I just break it. So I'm going to do continue. Okay, let's do the same. Why am I getting printed? Because I use the print box function. Let's comment it out. It is not required. Now it is good. Now you see 4 plus 2 6 plus 3 9 plus 4 13 objects printed. What I'm going to do, I'm going to increase the contour area to mask the value. So I'm going to keep anything under 1000. I'm not going to display the contour object. Anything above the 1000, I want to print it. Let's do that. Can you notice now? There was one object over here which was missed because that object is lying between 900 to 1000. That's why it is not printed, because I'm interested to show anything above the 1000. Anything under the 1000, I'm just going to skip it. Okay, now you understood. So let's bring it all 13 objects. Okay, cool. So now we understood what is the use of contour area and how we can remove the unwanted objects. Now the next step, what I need to do is I have to create the bounding rectangle object on top of each object. For that, what I will do, I will again assign the image. You don't need to assign the image, it's in the for loop. So let's not assign the output to the image object. Let's just draw the contours. And the second time what I'm going to do, the first one is drawn the contour, and the second one I'm going to make a rectangle border around the object. For that, the very first we are getting the each individual contour points, and second we are getting the bounding box coordinates using the box points. So this box I'm going to pass the value over here, box. Let's see, is that enough? And this one I'm going to highlight with white. So all three colors you make it 255. Let's make the thickness to 1 so that it will be differentiated from the contour and the surrounding box. So far we are good. So next what we need to do, we need to loop through each individual box. As you see, the box is going to print at any given time 4 values with x comma y columnar data. The x will be 352, y will be 464, and in the second row it is 293 and 464. For every iteration, one value will be shown, and this box is going to have x and y coordinates, and of course we have inside 4 different values. So that is why I'm going to assign it using for loop x comma y equal to box, and then I'm going to assign the box output to the individual variable top left, top right, bottom left, and that value will be in the combination of 4 different outputs. So enclose them in a single quote, and before that let's understand what is that xy is going to hold. So I'm going to print x comma y. Do that. You see now, for each interpretation the x is 352 464 followed by 293 464. So all this is going to provide the each corner points of the bounding rectangle of each individual contour. So what we do immediately, let's use this XY coordinates and draw the circle dots. Okay, I'm going to do the dot on the image. Using the CV2 dot, there is a function called circle, and here you need to pass the image against where you need to draw the dot. The image name is contour underscore img, and the x coordinate and the y coordinate you have to pass. As the x and y coordinates is already converted to integer format, I don't need to further convert. Let's pass x, y, and the radius you have to define. The radius I'm going to keep 2, and the color I'm going to make it red color, that is in RGB format. So 255, 0, 0, and the thickness I'm going to keep it 2. Is that code is correct? No. The x, y is a tuple points to be passed as a single value. So make sure x, y you're giving in a tuple, that is x, y within the parenthesis. Now let's run. There you go. Now we made the corner dots of each individual contour object. The very first is done. All we need to do now is we need to identify the midpoints. Okay, let's do the midpoint calculation. For that only we have initiated already the assignment. Top left, top right, bottom left. Now we need to calculate the midpoint for each of the boxes. That means you should have one more dot here, 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 here. How do we do that? We need to calculate the midpoint. The midpoint can be easily calculated using the top left, top right. And that is going to return 2 coordinates. Okay. So let's make that. I'm going to call the midpoint as TLX, TRX. This is one tuple point. This is equal to midpoint of TL, TR. And the second midpoint, so I'm going to call it as RX, BLX. And here again I'm going to call the function midpoint of BR, BL. Okay, where is the midpoint definition? The midpoint is nothing but the value what you pass. You need to add them and divide by 2. That's all we need to do. And when we pass the value TL and TR, what will happen? So here you see the box is having 4 different rows, and each row is having it 2 cells, x, y coordinates. So the TL is having that, this is called TL and this is called TR, and this will be BR and this will be BL. Each one is having 0 index and 1 index. Okay, so let's pause that. I have introduced the midpoint definition. Let's introduce the midpoint function. How do you define the function? DEF midpoint, and what are the values we are passing? We are passing 2 values, that is PTA, PTB. Go with a colon to define the function. And here I'm going to return the value based on the input value what I pass within the open parenthesis and close parenthesis. Make sure you're going to add PTA of 0th index. I'm going to read, that is nothing but this output. This is the TL, this output and this output. If I add and divide by 2, that will give me the midpoint. And similarly on the y-axis, this and this I will add and divide by 2. So the point A of 0 plus point B of 0, this output I'm going to divide by 2. This is one output, and the second output is, just copy the same, and this one I'm going to pass the index 1, and there we go. You have to make one more parenthesis closed. this parenthesis closing here and this parenthesis closing on the outside. I think we are good. That's all. So now we calculated the midpoint for the top left, top right, bottom left. Immediately let's draw the circle. Draw the midpoint dots. Copy the circle command from the top and paste it here, and all we need to do over here is we need to pass the value what we have calculated from the midpoint. Let's label this calculate midpoints. Okay, and I'm going to pass this tuple in place of x comma y, and this time I'm going to keep the radius 1, and this also I'm going to keep the thickness 1. My midpoint is returning the float value because I'm finding the median of 2 points using the divide operator. So obviously this will return in float, so I need to convert into the integer. Let's do that right away. Int of this, int of this, that's it. There you go. Was going with 1, I'm not able to differentiate the dots. Can you see now? We have got the middle dot for each rectangle object for the bottom side. So let's make it proper. I think we don't need this print box. With that, we already understood how we are going to interpret the data. Let me remove this line. There are 2 midpoints I have. I'm going to draw it and print this line one more time. And this time I'm going to substitute the second midpoint. That is BRX, BLX. We are good. Let's print it. You can see that the median dots are printed top and bottom. Okay. Let's label proper. Draw the midpoint dots for top and bottom. Now let's repeat this step to be printed for leftmost and the rightmost. So I'm going to rename the label with the reused code. This is for top and bottom, and this will be for left to right of rectangle. Okay, in place of top left and top right, I have to pass the value this time top left, bottom left, and similarly top right, bottom right. I'm good. You see that now? This time it got printed the middle dots for top and bottom of the rectangle. So we got the midpoints for each of the contour object. All we need to do now is we need to make a plus mark line. We need to connect the 2 midpoint using the line command. The first midpoint what I have TLX and TRX, that is one starting point, and the BRX and the BLX is the second point, start and end. Let's connect them. I'm going to add the line immediately after drawing the midpoint. Let's comment it out. Connect the midpoints using line. CV2 dot line cont underscore image, and the x coordinate, that is the start coordinate, and the end coordinate we have to provide, and the start coordinate in this case is this one, comma, and the end coordinate is the second dot, and the third one is the color, and the thickness, fourth. So I copied all the required information. All I need to do is I want to make a white line, 255. I'm going to keep it, the thickness of 1. Can you see the lines are drawn? It's connected. I have to make the another midpoint connection. So copy this code. From the second midpoint below that you make a line. That's it. Now you got the intersecting line. Now all we left out is we just have to print the size in pixel or in centimeter on top of each bounding rectangle on the contour image. That's the only exercise pending. Let's do that right away. Let's comment it. Calculate the distance based on the midpoints. Okay. How do we calculate? We have the SKImage package. Using that we can calculate. Let's do that. Let's assign the distance output to the dA for the first midpoint. dA equal to, what is the alias we have provided for the SKImage package for the distance calculation? It is dist. Dist dot, there is a function called Euclidean, E-U-C-L-I-D-E-A-N, Euclidean of the midpoints. What is the midpoint we have? For the first one, this point provided, comma, the second tuple is this one. Pause it. This will calculate the distance between the two midpoints and the value will be assigned to dA for the first object, that is the width. Let's print this line immediately after the line has been drawn. Okay. Now just place the same function again for the second midpoint calculation, and the variable this time we are going to differentiate for width and height. I'm going to make dB. Okay, now we got the distance between the two midpoints, and this value we need to just print it on the image. Before that, let's ensure is that producing any error message? No error message. We just have to print the label. Print the size in pix on each contour rectangle. Okay. Using the OpenCV package, cv2.putText, and within parentheses you need to pass the parameters. The very first parameter against what you need to print the image, that is contour image. And the second parameter we need to pass the calculated distance with the custom format, and the format I'm going to keep .1 decimal point, that is .1 float, and I'm going to suffix px because it's in the pixel format, and the format I'm going to substitute the value dA, the one which I calculated. So I'm passing that value, and where I'm going to print this label I'm going to print it and the first two coordinates, and this should be printed by taking 10 points backwards so that we get the space and print it just above the bounding rectangle. Otherwise it will overlap on the bounding rectangle. So I'm taking the indent 10 points backside, and similarly for the other axis -10, and this is the X and Y position. Then we need to pass the font, and the size of the font, and the foreground color of the text, and the thickness. And this should be a tuple value, so let's make a open parenthesis and close parenthesis for the entire value. I'm going to print the text right after the first midpoint calculation and the distance is calculated, that is assigned to dA. Let's print the same after we calculate the second midpoint. And for the second midpoint, we need to use the bottom right and bottom left. Let's change it. That is B or X. And this time we need to make plus. We need to show right side. And then the other one is BLX. And this we need to plus it with 10 points so that the text will be printed in the right side after the bounding rectangle. I guess we are good, and I think we need to change the second distance that is assigned to the dB variable. Print it. We are good. I hope you enjoyed this exercise and the tutorial. I know that it's a long exercise, but I'm pretty sure you would have enjoyed it. With this, I'm going to end the recording. If anyone was not subscribed my channel, I request you to subscribe, share and comment. Until I come back with another technical video, this is Saravanan Vajravel signing off from OneTouchBI. Have a great day.